Boyle's law.
What we're demonstrating here in this experiment is Charles' law. And Charles' law is V1 over T1 is equal to V2 over T2. And as that goes, as volume increases, temperature will increase, and vice versa. And that's when the amount of moles are kept at a constant. So what we're doing is we have two ping pong balls, and one of them is crushed up and has dimples in it, and the other one is normal. And what we're doing is we're placing the crushed one up in boiling water, and we're putting the normal one in the freezer. And if it goes as Charles' law follows, the normal ping pong ball will be compressed in the freezer as the temperature decreases, and the crushed one will expand to its original form or even further. It's already back to its original form. The ping pong ball in the freezer stayed the same without any impact because change in the temperature over the time, which was approximately 10 minutes, and the temperature of the freezer was not drastic enough to impact the volume. So in Charles' law, what's happening is as you add the heat to the substance with the molecules in it, it's exciting the molecules, and they're moving quicker with more kinetic energy, and as they move around, they're expanding the volume of the container which they're in, and thus it increases the volume. And vice versa, it works the same. If the amount of temperature is decreased enough, the molecules move slower, and the pressure can act in on the volume, and it crushes it in more. So in this experiment, what we used was Charles' law, and there was a change in the amount of volume. So we used the changing formula, which is P1 times V1 over T1 is equal to P2 times V2 over T2. And that's the equation we're going to start with. And what we're going to do is make the list of knowns and unknowns. So we're starting in the same pressure and ending in the same pressure, which is the room pressure. So we're going to say P1 is equal to 1 atmosphere. We're going to go ahead and say that P2 is equal to 1 atmosphere. And the starting temperature is about 20 degrees Celsius. And 20 degrees Celsius is equal to 293 Kelvin. We went ahead and we boiled the water, and that's 100 degrees Celsius, which equals out 373 Kelvin as well. And the volume we started with, we measured the volume of the crushed up ping pong ball, and what we got when we did that was 307.1 centimeters cubed. And in this problem, we're not going to use liters because it doesn't need to cancel out, and we're going to end with centimeters cubed as well, so there's no need to convert it to liters. And V2 is our unknown. That's what we're trying to find. So what we're going to do initially is write the equation again. We're going to go ahead and cancel out what we don't need, and then rewrite it again in the equation finding for V2. So P1 and P2 go ahead and cancel each other out. And then after you rewrite it, since you're finding for V2, you're going to go ahead and multiply each side by T2. And when you do that, you're going to get V1 times T2 over T1 is equal to V2. And after you go ahead and plug all your variables in, you get 37.1 centimeter cubed times 373 Kelvin over 293 Kelvin. When you do the math, the two units, the Kelvin, cancel out, and it leaves you with centimeter cubes. And after multiplying and dividing, you end up with 47.23 centimeters cubed. And that's your new volume. And the new volume, the change in volume of the ping pong ball after it was heated up.